Hello, this is Dr. Hanaa Assil and this is about orbital hybridization. So let's take a look what that means. For a carbon atom, you know that a carbon atom has 6 electrons total. It is in group 4. It should make a total of 4 bonds, whether they are all 4 single bonds or involving double bonds or involving triple bonds. So we need the carbon to make a total of 4 bonds, and that means the carbon, each carbon should have 4 unpaired electrons to share with the other atoms. But the problem is when we distribute the electron distribution for carbon, it is 1s2, 2s2, 2p2. So we have only 2 unpaired electrons. We need 4. So it was decided that we're going to mix up the orbitals in the 2s and the 2p, and we're going to distribute all the 4 electrons into the s and the 3p, and regard the s and the 3p as equivalent orbitals. These are called hybrid orbitals. So, hybrid orbitals are made by combining electrons, usually from the s and p, because the s and p are very close in energy. So we're going to mix all the orbitals of the s and p and regard them as equivalent. So now we have 4 unpaired electrons, and we can choose from that which electrons we need to make which type of bonds. So the type of hybrid orbital that is formed will depend on the type of atomic orbitals that are mixed. Am I going to take all the s and the 3p's, or the s and 1 of the p's, or the s and 2 of the p orbitals, and so on? These are all types of hybrid orbitals. For example, in methane, methane is a carbon with 4 sigma bonds. That means there are 4 equivalent bonds for orbitals from the carbon sharing electrons with the orbital of the hydrogen. So I need 4 equivalent electrons, and that means I'm going to take all these electrons, 1 in the s and 3 in the p orbitals, and regard them as 4 equivalent orbitals. Each of them is an sp3 hybrid orbital. So in sp3, we're hybridizing 1s and 3p orbitals, and each of these orbitals is now called an sp3 hybrid orbital. And we know that if we have 4 pairs of electrons shared, we need to arrange them with minimum repulsion between the shared pair of electrons. So this kind of molecule that has sp3 hybridization has a tetrahedral structure with bond angle 109.5. What if we're talking about ethene? Now, what do we have in ethene? We have each carbon, remember we're talking about each carbon. Each carbon needs to make 3 sigma bonds and 1 pi bond between it and the neighboring carbon. So the carbon needs 3 equivalent orbitals, each having 1 electron, so that it can share with the 2 hydrogens and the neighboring carbon to form 3 sigma bonds, and that means I will need 3 unpaired electrons. So I'm going to take the electron in the s and 2 of the p's. That is called sp2 hybridization, and each of these orbitals is now equivalent, and it is called an sp2 hybrid orbital. Now to arrange 3 orbitals so that, or 3 shared pairs of electrons so that they have minimum repulsion, this would be a trigonal planar structure with bond angle 120. What about the pi bond? Well, we still have, for each carbon, we have 1 extra electron in the p orbital, in the pz now, and that remaining p orbital on each carbon will overlap to form the pi bond between the 2 carbons. So if we have 3 sigma bonds, the hybridization is sp2 hybridization, trigonal planar, bond angle 120. Okay, what about in ethyne? Ethyne is a molecule in which there is a triple bond between the 2 carbons. And we already know that a triple bond means 1 sigma and 2 pi bonds. So the carbon needs to make a sigma bond with the hydrogen and a sigma bond with the neighboring carbon, and then it should have 2 more electrons to make 2 pi bonds with the neighboring carbon. So when we're looking at the hybrid orbitals, I need 2 of these electrons. That means I'm going to take the s and 1 of the p's, so that is an sp hybridization, and that means I still have 2 electrons in the other 2p orbitals that each of them will overlap with the corresponding one from the other carbon to form a pi bond. So in a triple bond between the 2 carbons, what we have is sp hybridization. So we have a hybrid orbital made by mixing 1 s and 1 of the p's. These 2 sp hybrid orbitals have to be spaced as far away from each other as possible for minimum repulsion between the bonding pairs of electrons. So the structure is linear with bond angle 180. And we said the other 2 electrons for each carbon will be used to make the 2 pi bonds between the 2 carbons. So remember, ethyne or a triple bond is sp hybridization, and this is linear with bond angle 180. A double bond would be sp2 hybridization, trigonal planar with bond angle 120. Methane or 4 single bonds needs sp3 hybridization, and that is a tetrahedral structure with bond angle 109.5. Okay, let's take a look at some questions. Which molecule contains a nitrogen atom with sp? Remember we said sp hybridized orbitals means we must have a triple bond somewhere. So the carbon has to make a triple bond with the nitrogen, and this is not present in the other options because we said the triple bond means 2 sigma bonds. So these are sp and sp, and the 2 extra electrons in the 2p orbitals will be used to form a pi bond. So HCN has sp hybridization. What about a double bond? A double bond in an alkene is made from sigma and pi. Identify the hybridization in a double bond. We said in a double bond we need the carbon to make 3 sigma bonds and 1 pi bond, and we said the 3 sigma bonds needs 3 electrons, so we're going to take sp2 hybrid orbitals, and the extra p is the one that is used to make the pi bond. What about this structure? We're asked this compound has how many sigma bonds and the type of hybridization. Okay, What is this compound? This is a compound that has double bond between the carbons and triple bond with the nitrogen. And we said each of these bonds must have at one sigma. So we have one sigma bond between the C and the N, and in the double bond, one of the bonds is a sigma, and all the single bonds are sigma, so the total number of sigma bonds is what? 6, right? So the total number of sigma bonds in this compound is 6. So my answer is C or D. Now, what type of hybridization? We said that depends on what the carbon is doing. If the carbon is making triple bond, that means we need 2 pi bonds, then my hybridization is SP. Now, a double bond means the carbon is making 3 sigma bonds, so it needs 3 electrons, so sp2 hybridization, so my answer is C. Both sigma and pi bonds are present in this molecule. Show the number of carbon atoms with each type of hybridization. Now, I'm going to remind you again, sp means a triple bond. sp2 means a double bond. sp3 means a single bond. So, sp is triple. Do we have any triple bonds? We don't. So, we don't have any sp hybridized orbitals. What about sp2? sp2 is the one in which we are making 3 sigma and 1 pi. So sp2, I have 2 carbons because we're asked for the number of carbon atoms. So these are 2 carbons with sp2 hybridization. Now sp3 is any carbon that makes 4 single bonds. So if we count how many carbons here, it is a total of 6 of them that are making 4 single bonds. Okay, what about this molecule? This is nitrogen. It has a lone pair of electrons and it is making 2 sigma bonds and 1 pi bond. Now, what is the electron distribution of nitrogen? Nitrogen has 7 electrons, 1s2, 2s2, 2p, 3. How are we going to distribute these electrons? We're going to hybridize the S and the P, so we're going to assume that the 2S and the 2P are of equal energy or similar orbitals, so that in order for the nitrogen to have a lone pair of electrons and 2 sigma bonds, we need to take the S and 2 of the 2p orbitals in order to make 2 sigma bonds and 1 lone pair of electrons. Of course, we still have an extra electron in the third p orbital. That is the one that will be used to make a pi bond with the other nitrogen. So the hybridization of each nitrogen is sp2. Which statement about this molecule is correct? Okay, let's take a look. The first choice says each molecule contains 1 sigma and 2 pi bonds. No, because when the nitrogen makes a double bond with the oxygen, the double bond is actually 1 sigma and 1 pi. And then there is another sigma with the chlorine. So actually that molecule has 2 sigmas and 1 pi. It is a non-polar molecule. No, actually, this molecule is polar. It has electronegative elements and it would have a polarity in the molecule since oxygen and chlorine are polar, and nitrogen also has lone pair of electrons. Anyway, so the molecule would be polar. Is it linear? No, it's not linear, because the nitrogen has a lone pair of electrons on it that repel the bonding pairs of electrons more than the bonding pairs repel themselves. The nitrogen atom is sp2. Yes, we said the nitrogen, we're going to take 2 electrons in the 2s, that is the lone pair on the nitrogen, and we're going to use 2 of the 2p's to make the 2 sigma bonds, and I still have 1 p orbital left to make the pi bond between the N and the O. So actually the hybridization of nitrogen in this molecule is sp2. Complete the table to show the number of sp2 and sp3 hybridized carbon atoms. Again, I'm going to remind you, to be sp2, it should have a double bond. To be sp3, then it needs 4 sigma bonds or 4 single bonds. So the number of carbon atoms that have sp2, I have 3 of them making double bonds with the neighboring atoms. So I have 3 carbon atoms with sp2 hybridization. The ones that have sp3, I have that one that has 4 single bonds coming out of it. That is an sp3 hybridization. Describe the covalent bonds present between carbon atoms in ethene. So we said ethene is this kind of molecule. So each carbon atom has how many sigma bonds in the bond, the sigma bonds involved in the carbon. Each carbon has 3 sigma bonds, and we said the 3 sigma bonds are made from sp2 hybridized orbitals. Now the pi bond is made from a p orbital. How do the orbitals overlap? Remember that any sigma will overlap head to head. A pi would overlap side to side. So remember that if I have sigma bonds in the carbon, if we're talking about what is the type of orbitals, each of them is an sp2 hybridized orbital. And that's the end of this. I hope this was useful to you. Thank you for listening.